Good morning, everyone. Today I will be going over long division. I had someone ask me some questions about long divisions that had like middle school age students, so I decided, okay, let me try to go into what long division is and how it works. All right, so something that you may have never been told about long division, and this is the way that I kind of see it, is that long division is pretty much like glorified subtraction. So it's just another way that we can use to subtract things. That's one of the functions of it. The other one is a way that we can group things. All right, so we look at it in terms of subtraction and or grouping. All right, so I'm gonna point out the parts and then I'm gonna do like an explanation. All right, so right here is the quotient. Anytime you get your final answer from division, that number right there represents your quotient. The number that's being divided, that's 16, that's what we call the dividend. The number that goes into the dividend is called the divisor. And then if there's anything left over, we call that a remainder. All right, so I'm going to go into one explanation where I talk about glorified subtraction, and then we're going to look at the process of long division. All right, so I'm going to put this in the context of a story now. So you are a young entrepreneur in elementary school with $16 that you want to use for starting a charity fund. This fund is to help students who cannot afford school supplies. You decide that your charity will donate $3 to students in need who qualify. How many students can your charity help with the $16? So this is a type of question that I would ask even before students knew anything about long division. Like, this is a question that can be figured out without long division. So we're going to start there to see if they can get to use some of their basic knowledge skills to even figure it out. So when I talked about division being a glorified subtraction, that is the approach that some might look at to figure this question out. So glorified subtraction. Here we go. We have $16. And remember, based on the situation in the story, you're going to be donating $3 to each person that needs help. So the best thing I would do is, if I didn't know what to do, that'll be the first thing I did, was like, okay, I'll subtract and then I'll get 13. So the question is, okay, so you know you can help one person, but do I have enough where I can help another person? That answer should be a yes. So, okay, let's take away another 3. You know what I'm saying? So we take away another $3, and then now I have $10. So I know I can help 2 people, right? Do I have enough to help someone else? And if the answer is yes, you keep subtracting. And so now we're down to $7. Is that enough to help somebody else? Of course it is. So I'm going to take that $7. I'm going to subtract another 3. And now I'm down to $4. Is that enough to help another student? And the answer is yes. So I take away another $3. Now I have $1, right? Is that enough? And the answer is no. So this is where you stop. Glorified subtraction. Now, remember, you're talking about long division, or that's the goal. The goal is to talk about long division, but we kind of base it off of something that we already know how to do, which is subtraction. When you do this problem, once you get to the part where you can stop at the $1, have your conversations. That's when you want to start talking a little bit more. Like, okay, so how many students were you able to help? You get what I'm saying? How many students were you able to help? Because remember, we never really answered that question. All we did was keep subtracting until we didn't have enough to give out anymore. So if they can start deciphering through their own numbers, and then they can count and tell you why they know how many students there are, then you know that they're almost ready for the long division. Now, the other thing is, not only can you ask them how many students did you help just off of this one, you can ask them, okay, so how much money did you give out total in charity? You know what I'm saying? That's another one, because all of these numbers that you're asking them are going to be numbers that's going to pop up one more time when we start doing long division. All right, so let's talk about how many students that we help. Remember, every time we take away $3, that's a student got help. So that student was helped. We had another student that 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 was helped. So I circled everyone that got help. So how many people were helped? 1, 2, 3, 4, 5 people were helped. Everybody see that. Every time I took away $3, that was somebody that got help. So 5 people got help. So 5 students were helped, and that's how much money went out to all 5 students. So $15 went out to these students that were helped total. So remember, 1, 2, 3, 4, 5 students got help. But there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, $15. So there it is. 5 students were helped, and that was $15 from the charity that was spent to help these students. All right, so glorified subtraction works, but it works best when the numbers are small enough. So remember, when we talk about mathematics, right, all of your numbers aren't going to be single digits or even less than 50, right? Sometimes you're going to get into some higher numbers, and then you got to come up with a better way than just saying, I'm going to just keep subtracting this number over and over and over again. It takes up more paper, and it just takes up time. So there's an efficient way that we actually do this same problem, and that's where long division comes in. All right, so here we are. We're looking at a long division problem now. And one of your main things that you have to know is place value. So the first place that I'm looking at is right here, which is the tens place. And this is where you have to start thinking. If I put a 1 right here, that 1 doesn't represent 1. That 1 represents the number 10 because it's actually sitting in the tens place. Does that make sense? So can I have $3 10 times? And that should be a no, because if you did have $3 10 times, what you'll have is a 30. So we already know that right now we can't use a 1 right here. And that's why that part gets ignored. All right. So now let's think about it. A 9. What about 9 times? That'll be too much. That'll be 27. 8 times? Nope. That'll be 24. We count all the way down, but the number that you can use is a 5. All right. So I can do $3 5 times, because what happens is that's a total of $15. There's your total of $15. And if I subtract to see what I have left out of that, what I have is $1 remaining. So I still have $1 remaining. And how many people was I able to help? 5 people. Notice how much quicker this is. Notice how much quicker that is. And everything that we asked about in the previous example, those numbers showed up. We were subtracting $3 over and over and over again. We were able to help 5 people. The total amount that went out to those 5 people was $15, and there's your $1 remaining. Everything that we got from the glorified subtraction were the same numbers that we can use in a quicker way using long division. I try to think in terms of money at all times when I'm teaching. For some reason, that's the only thing that gains interest. A lot of times, it's other situations you could throw out there other than money. But money is the one that's kind of important, being that we live here in a capitalist society, and you just got to have money to just do things, right? So a good way to teach this one, or a good way to work with your kids on this one, is if you invest in a Monopoly game. If you invest in a Monopoly game, you at least have play money that you can play with, or you just go and see if you could just buy some sets of play money, or make up your own play money using index cards, putting $5, $1, $20, $100 bills together and just make your own bills. But if you make them, hold that $16 in their hands, and you make them group those things out into $3 a pop, they'll start understanding how to divide. They'll understand the grouping and how that actually works. And then you can start training them to think the right way. And we'll train them how to write it down. That's when it's all said and done. Like mathematics, the writing down of it and the calculation part, that's just the work, right? But the real work is the concept, right? If they can get that concept, we can show them how things are written. So work with them on, physically just moving things and grouping things. And that'll get them a strong foundation just in division and multiplication alone. It'll work wonders. Like they'll be ready at the much higher levels when they get to me, because I teach advanced placement mathematics. So like you'd be surprised how many people don't understand the concept of long division. So that's my example for today. There's one more thing I kind of want to talk about. And since this whole situation was about a charity, right, and they understood how it worked, maybe you should talk about what charities mean or whatever. So like they were able to help 5 students in this situation. Start asking them, how could they help more students? Where would you get the money from? Fundraisers, donors, backers, investors, stuff like that. Get them all the way into that situation, and then make them start a charity for real. You know what I mean? So, you just never know. It might turn into like this big project where they actually in the real world get to help students $3 each. All right, so that's all I had to say. I'm gonna put up the link to my YouTube. Subscribe, like, share. See you tomorrow.